And what then happened was very illuminating. Within a few hours, Dirk Dekker handed in a true solution with its correctness argument. Dekker had first analyzed the proof obligations, then chosen the shape of an argument that would meet them, and then constructed a program to which this argument was applicable. It was a very clear example of how much one loses when the role of mathematics is confined to a posteriori verification. And in 1968, I would publish a paper titled A Constructive Approach to the Problem of Program Correctness. But the seed for that was sown by Dekker. Dekker's experience. What's the name? No. Yes. Okay, here's next. There was Article 60. We saw it coming in 1959 and implemented it in the first half of 1960. I was terribly afraid, for this implementation was then by far my most ambitious project. Article 60 was so far ahead of its time that even its designers did not know how to implement it. I had never written the compiler and had to achieve my goal with a machine that had only 4,096 words of storage. The word was 27 bits, not counting the parity bit. Okay, that way I had such a small storage that letter constraint was, of course, a blessing in disguise. But I don't remember it seeing that way when we started. By today's standards, we did not know what we were doing. We didn't dream of giving any guarantee that our implementation would be correct, because we knew full well that we lacked the theoretical knowledge that would be needed for that. We did the only thing we could do under the circumstances, that is to keep our design as simple and systematic as we could, and to check that we had avoided all the mistakes we could think of. Eventually we learned that we had made mistakes we had not thought of, and after all the repairs, the compiler was no longer as clean as we had originally hoped. And as a matter of fact, Kruseman and Retz still found and repaired a number of errors after I had left the mathematical center. I had an illuminating experience in 1962 in Rome. There was a conference and we were sitting in a long big circle talking about God knows what. And there was an American, that was a time you should realize, 62, that's people who had written compilers. They were a type of demigods, and in a circle there were all those demigods sitting, and there was an American who was very proud of his achievement, and he boasted that he had constructed a algebraic compiler, or algebraic translator was the name at the time, of 55,000 instructions. And immediately he was outdone by one of his compatriots who told proudly that he had done a algebraic compiler of more than 80,000 instructions. And then Peter Nauer said, well, my algo compiler only took 5,500. And then I could outdo him and say, well, mine only took 2,700. The sign of the pride pointed in different directions at different sides of the Atlantic. Now, right from the start, we expected two very different types of errors. Writing errors whose repair is trivial, and thinking errors that would send us back to the drawing board. And the distinction has helped us because one combats them by different techniques. Sonneveld and I combated the writing errors by coding together, each with his own text in front of him, claiming that we would write two identical books. When we were done, both our texts were punched independently, the two tapes were compared mechanically, and about 24 discrepancies showed up. The thinking errors we had tried to prevent by convincing each other why the proposed section would work. In this reasoning, we would mainly discuss the workings of the compiler, while the compiled program was treated as data. And this experience has been helpful for later, as it made us accustomed to non-operational considerations of program texts. Now, the whole experience has made me sensitive to what later would be called modularization, or divide and rule, or abstraction, to the care with which interfaces have to be chosen, and to the potential scope of the programming challenge in general. It has heavily contributed, partly of course due to my own failures, to my subsequent opinion that creating confidence in the correctness of his design was the most important but hardest aspect of the programmer's task. In a program, in a world obsessed with speed, this was not always a universally popular notion. I remember from those days two design principles that have served me well ever since.